Section 1.2, Algebraic Expressions and Models. Example 1, evaluating algebraic expressions. If we look at 2 to the 5th power, that whole expression is called a power. The number 2 is the base, and the number 5 is the exponent. We'll look at 4 examples here where we'll evaluate the following. The first one, example A, we have the quantity -3 to the 4th power. This means that we are going to multiply -3 4 times. Now remember, if you multiply a negative times a negative, that gives you a positive. So we can see here I'm multiplying the number -3 an even amount of times. That's going to give me a positive 81. This example B is different. You can notice that the negative sign is not in parentheses. That means you're multiplying 3 times 3 times 3 times 3, or that negative sign stays in the front of the calculation. So this will give me a final answer of -81. So you can see that it makes a difference whether the negative sign is inside the parentheses or if it's outside of the parentheses. If we look at examples C and D, we have the same idea here. However, notice that the exponent is odd. So if I multiply the quantity -3 times -3 times -3, that's going to give me a -27. And if I look at the negative sign not in the parentheses, that also gives me a -27 for my answer. So you can see the difference when the negative sign is inside the parentheses, when it's outside the parentheses, and when the exponent is even versus when the exponent is odd. Here in example 2, we're evaluating an algebraic expression with variables. Remember, a variable is a letter used to represent a number. If I wanted to evaluate the expression -3x squared minus 5x plus 7 when x is equal to -2, that means I'm going to substitute -2 for x, and we'll square that -2, which will give me a +4. We'll multiply -5 times -2, which will give me a +10. We'll multiply -3 times 4, which will give me -12. And then we'll add -12 plus 10 plus 7, which is going to give me +5. Example 3, write and evaluate a real-life model. So here you have $50 to buy movies that cost $15 each. We want to write an expression that shows how much money you have left after buying N movies. So first we'll write the expression, and then we'll evaluate our expression after we have purchased 2 movies. So if I want to write an expression that says that I have $50 to buy movies that cost $15 each, that means we're going to have 50 minus 15 times n. If I want to evaluate that expression after I've bought 2 movies, I'm going to have 50 minus 15 times 2, which will be 50 minus 30, which will leave me with $20. Example 4, simplifying by combining like terms. So in the expression 2x plus 3, 2x and 3 are terms. 2 is the coefficient, x is the variable, and 3 is the constant. Like terms, or examples of like terms would be 3x squared and -5x squared, and the constants -4 and 2 would also be like terms. So we want to look at simplifying the following expressions. The first one, we have 7x plus 4x. Those are like terms. We combine those, that's going to give us 11x. If we look at 3n squared plus n minus n squared, we know that 3n squared minus n squared, those are like terms. That will give me 2n squared plus n. And lastly, we have 2 times x plus 1, the quantity x plus 1, minus 3 times the quantity x minus 4. So we want to make sure we're using the distributive property. We're going to distribute 2, and we'll have 2x, and then 2 times 1, that'll give us plus 2. We'll distribute negative 3, that will give us negative 3x, and then negative 3 times negative 4, that will give us positive 12. Then we'll look to combine like terms. So we have 2x minus 3x, that'll give us negative x, and positive 2, positive 12, which will give us plus 14. So our final answer here will be negative x plus 14.